Look at almost any embedded product today. Thermostats, medical devices, industrial panels, wearables. Chances are they have a display and users expect a beautiful intuitive interface. Gone are the days when a few LEDs and buttons were enough. But bringing those rich graphical experiences to resource-constrained embedded hardware, that's a significant challenge. Thankfully, there are tools specifically designed for this. But just like everything else in embedded, the choices are abundant and varied. Hi, I'm Sarana Pandian, CEO of MVN Technologies. Over the last 23 years, we have built countless embedded products, and complexity and importance of the human-machine interface, the HMI, has grown exponentially. Building UIs for embedded systems is fundamentally different from desktop or mobile. We are working with limited CPU power, maybe only a few kilobytes of RAM, a few megabytes of flash, often no GPU or a very basic one, and displays with limited resolution or color depth. Every pixel drawn, every animation frame, every memory allocation counts. So, how do you pick the tool that lets you create a compelling user experience while respecting your hardware's limitations? The Embedded UI Tool Landscape. The Embedded UI Tool Landscape offers diverse approaches, each with its own strengths. Higher level frameworks. These offer comprehensive feature sets, complex widgets, layout managers, and powerful animation systems. They typically require a more powerful MPU running a full OS like embedded Linux and often benefit greatly from a GPU. Examples. Qt is a very popular framework that uses C++ and QML for design. Sometimes GTK is used for traditional desktop like embedded Linux app development. Android can be an option in this category. Pros. Rich features, excellent visual fidelity potential, good for complex applications, large communities, and documentation. Cons. Resource intensive, needing high RAM flash usage and CPU-GPU demands. They can have significantly commercial licensing cost per seat or per device. Lightweight graphic libraries. Designed specifically for resource-constrained environments, including MCUs or basic MPUs without GPUs. They focus on drawing primitives and widgets efficiently. Examples. LVGL, a popular open source option written in C, works on many MCUs and MPUs. MVN is a commercial library widely used. Our own Sparklet is a very powerful royalty-free library. Pros. Minimal resource footprint, high performance on limited hardware, portable and affordable. Cons. Less built-in fancy widgets or animations compared to high-level frameworks requires more manual coding for complex layouts. Visual design frameworks. These focus on providing strong visual designer and workflow that bridges the gap between UI designers and embedded engineers. They often use proprietary tools or code generation. Examples. Embedded Wizard is a powerful tool with its own language and workflow, and it generates highly optimized C code. TouchGFX is specifically for STM32 microcontrollers and is visually driven. Crank Storyboard Suite uses a tool that imports designs from other graphic tools and generates embedded code. MVN's Flint is another design tool with which the entire graphic story can be developed without writing a single line of code. Pros. Rapid UI prototyping and iteration enables designer-developer collaboration, generates optimized code tailored to the hardware. Cons. Can have a steep learning curve for the tool's workflow and language, commercial tool costs, and it can be vendor specific. The selection challenge. That's quite the spectrum, from tiny C libraries to powerful frameworks and visual tools. So how do you pinpoint the right tool for your product's display? It's not just how good the demos look, it's about a practical fit for your specific embedded constraints and project goals. You need a framework to evaluate these options against what truly matters in the embedded world. Let's get into the UI library selection framework criteria. Criterion 1. Hardware resources and capabilities. This is often the most limiting factor. What are your CPU speed, available RAM, flash size? Crucially, does your hardware have a dedicated GPU or a 2D graphics accelerator? High-level frameworks typically require a MPU with significant RAM and preferably a GPU. Lightweight libraries are better suited for MCUs or MPUs with limited resources or no GPU. Criterion 2. Required visual fidelity and user experience. What does the UI need to look like? Simple text and icons, smooth animations, transparency, complex custom widgets, multiple screen with transitions. The higher the visual requirements, the more capable the tool must be. Criterion 3. Real-time constraints and performance. Does rendering the UI need to happen within strict deadlines without impacting other critical tasks? How important is a high smooth frame rate? Tools designed for real-time integrations are better here. Performance benchmarks on target hardware are essential. Criterion 4. Development workflow and designer collaboration. How easy is it to design the UI? Is there a strong visual editor? Can UI designers contribute directly or work easily with the engineers? How quickly can you iterate on the UI design? Visual design tools offer significant advantages in this area. Criterion 5. Cost and licensing. What is the licensing model and total cost? This can range from a free open source option to per developer seat licenses, per project licenses, or even per device royalties for some commercial tools like Qt. There are royalty-free options like Sparklet, Flint 2. Read the terms carefully. Criterion 6. Programming language and ecosystem. What language is the tool based on? C, C++, or others? What language is your application logic in? Is your team familiar with it? What middleware or peripheral drivers are available and integrate well with the UI tool? Criterion 7. Target operating system. Does the tool run your chosen OS, bare metal, RTOS, embedded Linux, or Android? Some tools are OS agnostic, while others require a specific OS environment. Criterion 8. Vendor support and community. Is there a good documentation, tutorials, and examples? Is there an active community forum for troubleshooting? What level of commercial support is available if you get stuck on a complex issue? Beyond the framework, expert insights. While these criteria will help you narrow down the field significantly, but here are a few things my experience in the field have taught me. Benchmark. Never assume performance. Get a dev kit, implement a representative screen on your candidate tool, and measure rendering speed, CPU load, and memory usage on your target hardware. The graphics pipeline. Understand how the UI tool interacts with your specific display controller, frame buffer, DMA, and GPU. A tool might be powerful, but if the low-level hardware integration is poor, it won't perform. Designer-developer workflow is crucial. Don't underestimate the pain of bad handoff between UI designers and the embedded team. Tools with strong visual editors or clear design import pipelines can be game changers. Licensing can be complex. Get legal and business teams involved early to fully understand the licensing terms of commercial tools, especially volume royalties. Start simple, scale wisely. For initial prototypes or simpler products, a lightweight library might get you to market faster. You can consider a more complex tools for future product generations if hardware resources increase. Conclusion. Creating compelling user interfaces is now essential in embedded systems, but it requires navigating the constraints of your hardware. The wide choice of tools, from powerful frameworks like Qt, Android, efficient libraries like LVGL Sparklet, to visual suites like Embedded Wizard and Flint, means there is likely a solution for your needs. By systematically evaluating based on your hardware resources, visual requirements, performance needs, development workflow, cost, language, OS, and support, you can choose the embedded UI tool that lets you build beautiful interfaces successfully within your product's limitation. I hope this framework helps you select the right graphics tool for your next embedded product. If you find this video valuable, please give it a thumbs up and subscribe to the channel for more expert insights from Ambient Technologies. What's your go-to embedded UI tool, or which one are you considering? What challenge have you faced? Share your experience in the comments below. And if you need expert guidance on developing complex embedded systems with great user interfaces, visit us at ambient.com. Fill in the link given below in the description for a free consultation. Thanks for watching, everyone. Let's continue making embedded systems more intuitive and visually appealing. See you in the next video.